The origin of life is a question that has captivated humanity for centuries. The panspermia hypothesis offers a captivating alternative to the traditional view of life arising on Earth. This theory proposes that life exists throughout the universe and is spread by celestial bodies like meteoroids, asteroids, and comets. Imagine tiny microbes hitching rides on these cosmic travelers, journeying across unimaginable distances to seed life on other planets. The panspermia hypothesis challenges our anthropocentric view of life. It suggests that we are not alone in the universe and that life on Earth may be connected to a much larger cosmic web of life. The discovery of organic molecules in meteorites that have fallen to Earth has provided tantalizing clues. These findings suggest that the ingredients for life could have been delivered to our planet from outer space. The panspermia hypothesis opens up a realm of possibilities, suggesting that life may be more widespread and interconnected than we ever imagined. In the following sections, we will delve deeper into the different forms of panspermia, the scientific evidence that supports it, and the ongoing research that seeks to unravel this cosmic mystery. Panspermia, meaning all seeds, encompasses several variations on how life could travel through the vastness of space. One form, known as lithopanspermia, proposes that life can be transported within rocks ejected from a planet's surface during an impact event. Picture a large asteroid colliding with a planet that harbors life. The impact ejects fragments of the planet's surface into space, some of which carry microscopic life forms embedded within them. These life-bearing rocks then journey through space, potentially reaching other planets and seeding life upon impact. Another form, ballistic panspermia, focuses on the transfer of life between planets within the same solar system. This process suggests the possibility of life being exchanged between planets like Mars and Earth. Interstellar panspermia takes the concept even further, proposing that life can travel between different star systems. Over extremely long periods, objects ejected from one star system could potentially reach another, carrying life across interstellar space. The various forms of panspermia paint a picture of a universe where life is not confined to individual planets, but can potentially spread across vast cosmic distances. This intriguing possibility continues to fuel scientific inquiry and inspire our imagination as we explore the potential for life beyond Earth. While the panspermia hypothesis remains a subject of debate, several lines of scientific evidence have emerged that lend credence to the possibility of life being transported through space. One of the most compelling pieces of evidence comes from meteorites that have landed on Earth. Scientists have discovered organic molecules, the building blocks of life, within these celestial visitors. These molecules, including amino acids, sugars, and nucleobases, are essential components of proteins, DNA, and RNA. The presence of these organic molecules in meteorites suggests that the ingredients for life could have been delivered to early Earth from outer space. Further evidence comes from experiments conducted in space. Scientists have exposed microorganisms to the harsh conditions of space, including extreme temperatures, radiation, and vacuum. Surprisingly, some of these microorganisms, known as extremophiles, have demonstrated remarkable resilience, surviving these extreme conditions. These experiments suggest that certain life forms possess the hardiness to withstand the challenges of space travel, at least for limited periods. While these pieces of evidence do not definitively prove panspermia, they provide intriguing clues that support the possibility of life being transported through space. The early appearance of life on Earth has also fueled speculation about a possible extraterrestrial origin. Evidence suggests that life emerged on our planet remarkably early in its history, potentially within a few 100 million years after its formation. This relatively short time frame has led some scientists to propose that life may have originated elsewhere and was then transported to Earth. One celestial candidate that has garnered significant attention is our planetary neighbor, Mars. While Mars appears to be a cold and arid desert today, there is compelling evidence that it was once a much warmer and wetter planet, potentially harboring conditions suitable for life. Early Mars possessed a thicker atmosphere, liquid water on its surface, and a magnetic field that could have shielded it from harmful radiation. The exchange of materials between Mars and Earth through meteorite impacts raises the intriguing possibility that life could have originated on one planet and been transported to the other. If life did arise on early Mars, it's conceivable that Martian meteorites could have carried life to Earth, seeding our planet with the first organisms. While this idea remains speculative, the possibility of a connection between life on the two planets continues to drive research and exploration. Despite the intriguing evidence supporting panspermia, the hypothesis faces significant challenges and criticisms. Skeptics argue that while panspermia offers a potential explanation for how life might have spread, it doesn't address the fundamental question of how life originated in the first place. Critics point out that panspermia merely shifts the problem of life's origin to another location in the universe. If life didn't originate on Earth but was transported here, then it must have originated somewhere else. This raises the question of how life arose in that other location, a question that panspermia itself doesn't answer. Another challenge lies in the difficulty of testing the panspermia hypothesis definitively. The vast distances and timescales involved in interstellar travel make it incredibly challenging to design experiments that could conclusively prove or disprove the transport of life across such vast cosmic distances. The harsh conditions of space travel, particularly the intense heat generated during atmospheric entry, also pose a significant challenge. While some microorganisms have demonstrated resilience in space experiments, it's unclear whether they could survive the extreme temperatures and forces experienced during entry into a planet's atmosphere. The panspermia hypothesis inspires research into life beyond Earth. Astrobiology explores life's origin and potential in the universe. Scientists study organic molecules and extremophiles. They develop methods to detect life on other planets. Missions like Perseverance search for life on Mars. Future missions will explore icy moons for life. The panspermia hypothesis, while still a subject of debate, has the potential to revolutionize our understanding of life's origin and our place in the universe. If life on Earth did originate elsewhere and was transported here, it would suggest that life is not a unique phenomenon confined to our planet but rather a cosmic phenomenon, potentially widespread throughout the universe. This realization would have profound implications for our view of life itself. It would suggest that life on Earth is connected to a much larger cosmic web of life, with shared origins and a common ancestry, potentially extending far beyond our planet. The panspermia hypothesis challenges us to broaden our perspective on the origin of life and our place in the cosmos. It encourages us to look beyond our planet and explore the vastness of space with a renewed sense of wonder and curiosity. As we continue to explore the cosmos and unravel its mysteries, we may one day find definitive answers to the question of whether life on Earth is a solitary spark or part of a grand, interconnected cosmic tapestry.